So let's talk about a couple of the mechanics behind what Marta described. As we were talking earlier, we're polling every 30 seconds, and so we collect a great deal of data about those devices. The same kind of data that SNMP queries, we're just querying it all over the console ports. And because we do, we don't deter the device from being able to switch packets, and we don't really generate any network traffic for that. So it's a very efficient way to collect data about RX bytes, TX bytes, and all those SNMP variables that you get today. We just do it over the console port. And because we put it in a local database, we don't need any networking to be available. Even our out-of-band system doesn't need to be up to be able to collect data and put it in a local database. And then we use that data by passing it through a rules engine. Every time we collect data, we look at the rules engine again and say, what have we learned about this system that we didn't know a minute ago? And we'll take you through an example of that in just a minute of detecting and starting to react from a network outage. And then if nothing passes our threshold in the rules engine, we just continue monitoring. And so 99.9% of the time, we're just continuing to poll, looking at the data, seeing it doesn't exceed any threshold, and go back to monitoring. Now, you generally still have your network your core network monitoring systems, your SolarWinds and your Tivolis and CA Spectrums and products like that polling over the wide area network. It's just generally much less frequent than our system. So as we're polling every 30 seconds, we might detect that a T1 connection on that router went down. In fact, we were running a show interface or a show service module command, and we see that our frame loss seconds incremented. Our protocol state is up, but the operational state is down. Sorry, the operational state is up, but the protocol state is down. And so we might collect that information in the first 30 seconds that there's an issue, but we might not want to take an action all that quickly. So we might wait just a couple of seconds, and so we'll poll again 30 seconds later. We may see this same state again, and so then we have two instances of it, and we're starting to put together a contiguous problem. So 30 seconds later, let's say we poll again, we see it again, so we have three instances, two more times. In 2.5 minutes of this outage, we'll have 5 samples of it being a problem, and generally at that point we start taking automated first-level actions. The same stuff Cisco TAC would take you through if you'd called them and said, hey, I've got a frame loss seconds incrementing and an up-down state. So if you followed Cisco TAC or built your own, their first recommendation is to run the clear service module command against that. And so that's what the Uplogix appliance is designed to do, is to collect that data, triangulate it locally, and then take that first level action. If that solves the problem, which it does 10% of the time, we're back to monitoring and business as usual, and the network's back up within about 2.5 minutes. If that didn't solve the problem, then we'll take the next first level action. Cisco TAC recommends, or as Marta mentioned, you can add your own. Shut the port. See if that brings the connection back up. If that does solve the problem, then you're done in about 3.5 minutes from the time that the problem began. If it doesn't, you take the next first level action. Pull the show tech and store it away with all the low-level controller information. So if you have to open a TAC case, you have it from the middle of the outage. It generally takes about a minute to execute that step, but by the time that that's complete, you would follow on to the next Cisco TAC recommended best practice of doing a reboot. But before you do steps like reboot and power cycle, those low-level steps that often resolve problems, you need to make sure that the network tests, or that the network is not meeting its minimum service levels. And so we run synthetic tests over the network from that remote perspective. And one of the first ones that we might be running there is a voice over IP test, maybe a call between the Uplogix local manager that's in the rack and another Uplogix local manager across the network somewhere. And we want to see that from the voice VLAN that calls are not succeeding. And we use that to gate our automation in this case. And so as we look across the database at our tests, we see our voice calls are failing. We might also look at synthetic web transactions, maybe to an intranet site or to Google, just to validate that the network web page loaders are failing. This is, again, a gate of our automation, but it's also the ability to validate that those service levels are not being met. We might do another test that is just a TCP SYNAC round trip to some ERP application or some other application on your network. Again, it's another way that we validate that the business use of the network is failing at the remote site. Not only do we see loss of frame incrementing, operational state up down, but we also see these synthetic tests are failing. So it gives us more confidence to take broader level action. So if all those things are true, we're about 5.5 minutes into the outage. We take the reboot action because we validated, again, that all those other network components are down. And if that solves the problem, we're done in about 6 minutes. We come back up, we query again. We're still having the exact same state, and so we take a power cycle action by switching off that outlet with that power distribution unit over to the right. So in this case, that solved the problem. We're back to up and up, and the lost seconds are cleared, and we're back to business as usual. From the time the first packet dropped to the time of the resolution is about 8.5 minutes. That's really the remote's automation perspective of this of our product. But we also have a component that lives at the NOC called our control center, and we'll look at it from the control center's viewpoint. Those tools at the NOC, let's say it's CA Spectrum that you're using, are polling over the network as long as the network is up. But when the network goes down, that poll will show up inside Spectrum with devices not responding. You don't know what the problem is. It could be a backhoe, it could be an access control list, it could be a power problem. But basically, that's what your NOC provides for you today. And what the Uplogix appliance is designed to do by default is bring up an out-of-band connection from the remote back into the NOC after about 2.5 minutes of not being able to communicate. And it does that by doing a dial-up connection over cellular or analog dial tone, connecting back to the NOC, maybe building a VPN back in, and connecting to the control center. And then the control center has the ability to take those status messages from the local manager and backfill CA Spectrum and Tivoli and SolarWinds and all those products with the remote's perspective of the problem. So the first thing that we would see in our Spectrum dashboard, for example, would be those top two lines are what Spectrum generated, and what you see in the orange lines are what the Uplogix is doing about it. And so in our example earlier, the first thing that we noticed is that we have frame loss seconds incrementing in the protocol states down. So that's first of all going to be associated with that router in Spectrum, increasing the visibility and usefulness of that product in the middle of the outage. And the next thing you start seeing are the automated actions that the Uplogix is starting to take. The clear service module starting completed, the interface cycle, the show tech, the reboot, and the power cycle commands are all backfilled as they occur back into the graphical interface of the of CA Spectrum to let you know what the remote is doing, as well as to see current up to the minute state of the network. And in this case, after that power cycle, the in-band SNMP queries start to complete, and those systems go green again, and we're back to business as usual. We'll talk a little bit about that service level verification just to let you know how that's working. We're doing synthetic tests over the network to both give you a baseline of availability, but also, as I mentioned, to gate our automation. If we saw those loss of frame or interface state up-down messages, they generally wouldn't be enough to want to trigger an automated power cycle, but once we fail some of those business level tests, as we were saying, that's the assurance that you need, and the same kind of assurance that a first level tech would use to validate that it's okay to take actions like power cycle. In our voice test, we're doing basically a call across the network, just like when the Verizon guy says, can you hear me now? We're actually running real voices using your codecs over your network from point A to point B to validate that ability to make voice calls. or as I mentioned, simulated web transactions with DNS lookup and time to first and last byte and result code. All of those data points are used to help us and make that decision about the ability of the network to perform its tasks, or just that simple synthetic SYNAC round trip to prove TCP is up between point A and point B. So in this case, we would use the same routers and switches that the phone uses, and as it moves into its switch, its router, its WAN connection, back to another router and switch, we're looking at the layer 2 interfaces, bytes in and out. Maybe we're on our voice VLAN, and so we're looking at traffic and protocol status and load and really those things about layer 2 connectivity that make that call work. That's what we're doing by querying the router and switch directly. But then we do these calls and these transactions from the Uplogix appliance, from one Uplogix to another, and we're looking at layer 4 data. For example, in that voice call, we're looking at the RTCP values that come back from a voice call, and everything from jitter and latency and MOS scores and R values and drop packets, and all of those artifacts from the voice scoring go into our database right along with that layer 2 traffic, and we use all that together to make these decisions, which is really what our rules engine is designed to do, is decide and make decisions just like your first level techs would. Finally, this solution is really applicable across industries. Everyone has IP networking challenges and operational support challenges. These are some of the customers that have implemented Uplogix and use it in their operational networks as a core to their functionality today. What makes Uplogix different? Just to sum it up, we're always directly connected, right? Like SNMP, we get the same data, but we get it when the networks are down, which is really when you need this functionality. And then we poll very intensively at about 10 times the frequency of most network monitoring tools. We're a fail-safe safety net for making changes. Really, regardless of the change you make, we have the ability to recover from it, whether it's in the middle of a change window, or if you're doing troubleshooting in the middle of a live production network. We give you that ability to recover from finger fumbles and other diagnostics tests. We have a very flexible system of automation. We package best practice rule sets, give you the ability to tweak it, reorder it, retime it, really meet your operational posture for recovering from problems. We have a very granular roles-based management system that lets just the right people be able to do the right actions on the right devices, and then for systems that they don't have access to via permission, you can mask that. And then really we complement those existing tools like SolarWinds and Spectrum and Tivoli and those products by backfilling them in the time that they aren't actually able to do the querying across the network.